All right, so let's do the last 2 units. It's actually 1 unit. The 8.3 is just very small, short, and simple, straight to the point. Okay, so let's do 8.2. 8.2 is a little bit more involved, so I'll try my best. These are very fun for me. I love this section, but due to the time constraints, I don't get to explain them or do more examples. So let me just go about and explain this. You have all seen ellipses, ellipses, however you want to say it, in this world. They're basically egg-shaped, right? You have them horizontally, vertically, doesn't matter. It is basically a circle that got pushed down from one of the ends, right? Okay. So when you are thinking about an ellipse, you want to think of an egg that sort of got pushed down, got a little bit deformed, right? So notice that it's got the same exact portion on the top as a circle. Let me zoom in a bit. Basically has the same kind of equation from the numerator. The only difference is there's a 1 on the right and there are denominators on the bottom. So how do you want to do this? You want to be able to understand, and again, you can take a picture of this, you can use this on the exam, and you want to be able to know which one is which, right? You want to be able to know which one is horizontal, which one is vertical. And so the equation will be just numbers, okay? So you don't want to memorize the formulas because it doesn't tell, like the numbers won't tell you anything. You have to know how to read them, okay? So what happens is that I am going to show you and tell you which one is A. So when you see an equation, it won't do anything. You won't even know. You have to know who is A by these little rules and tricks that I have on here, okay? Which are the red ones. You always give exact answers. You should never, ever, 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 ever in this section of ellipses and hyperbolas have decimal answers in the denominator, ever, okay? Ever, okay? All right. So if that is the case, let's get started. I just have to send something, okay. The center again is the same thing as a circle. It's a dot in the middle where it helps you, it aids in you graphing the ellipse. However, it is not a part of the actual graph, okay? So if you remove the center, it wouldn't even matter. You just know that it is the center because of the work that you did and because of how you graphed it. So the center is given by HK, which I have written down here, okay? The amount of units going left and right will be A and B, and the amount of units going up and down is B. Over here, the amount of units going up and down is A, and then the amount of units going left and right is B. Now, you don't want to memorize this again. I will show you how to do these. So I'm going to do an example from start to finish on how you figure this out. So you want to know these two, and you also want to know this formula. This is not the Pythagorean theorem. Please, please, please do not make that mistake. This is not the Pythagorean theorem. That's why it is important that the A value is the largest. Notice here, A squared is the largest number. Why? Because that will give you a large number minus a small number, which would produce a positive number. If you mess these up, you'll end up with a negative, and then that will make sense. So that's why it's important that we know that the A squared is the largest number, so this formula could work. The major axis is basically the longest side. So they tell you that the major axis is on the x-axis, it means it's longer on the x. If they tell you the major axis is on the y, it means it's longer vertically. Where the longest sides are, those are called the vertices, whether it's horizontal or vertical. And the shorter sides are called coves. So I call them codes. Co-vertices, okay? Well, they're co-vertices. I just, shortened it, but it's co-vertices, co-vertex, each co-vertices, plural. All right. And then you have some focus points, focus point 1, focus point 2. Again, those are not part of the graph, but they aid in graphing an ellipse, okay? But since we're going to be graphing it in a different format, you don't really need them other than just to give it as information, okay? So we've got focus 1, focus 2, and the plural of that would be foci. That's F-O-C-I, foci. All right, so let's get started with this. I'm going to grab some graph paper because we do need it. However, this is a see-through graph paper. This is ridiculous. So sad. But I had gotten better graph paper. All right, graph and label all the parts. So if you were in my class face-to-face, you would have to label every single part. You'd get points up if you didn't. But you're doing this on Pearson, so you get a break. Okay, that is an ellipse. How do I know it is an ellipse? Number 1, because it's got a plus in the middle, okay? It's number 2, it's got both variables squared, just like a circle, okay? And number 3, it's equal to 1. Those are the 3 things that distinguish it from a circle and from a parabola. Let's just recap really quickly. The parabola, what makes a parabola a parabola? Only one of the variables is squared. That's it. A circle, right here. You have a plus in the middle. Both variables are squared. No denominators. Okay. All right. Let's get to it. These are fun. So let's just show you again the things you need. A squared is the largest. It's centered at HK, and it's got this. So let me write that information on the side. C squared equals A squared minus B squared. That's one thing we will use. You will then know that A squared is the largest. And center is HK. All right, so we need all this information on the right. Okay. Now, what we need to do is say, well, out of this, I have no idea what A is and B is. So that's why it's important for me to know that A squared is the largest. So I'm going to always start with center, dot, dot, vertices, that's plural, dot, dot, co-vertices, dot, dot, foci. Now, the reason why I do it in this order, and I know I have certain ways of doing things, but this I found is the easiest way because you know your ABCs, right? You are in college and you know your ABCs, and that's the same order that I ask students to do it. Okay, A, B, C. A are your vertices, B are your co-vertices, C are your focus points or foci, and this is your hint right here. Okay. The center is anything that's adding or subtracting to the x, which is nothing, and anything adding here is nothing. So it's 0, 0. It is centered at 0, 0. Okay. Once we have that, we're then going to state A squared is the largest. So you look at your denominators and you say, okay, which one's the largest, 16 or 4? 16 is the largest. So I'm going to say A squared equals 16. Therefore, B squared is the smallest one. And you solve for A. Square root, A equals plus or minus 4. Take square root, B equals plus or minus 2. I still don't want to fill these out. I don't want to fill them out because I still don't know. I'm not sure if it's horizontal, vertical. I still don't know. Let me show you how to figure it out. If the number that you chose, 16, is underneath the x, that 16, that 4 is going to move the same way the x runs. So it's going to be left, right. That number is below the y runs vertical. Okay. All right, let's keep on going. Let's find C. C squared equals A squared plus, oh, not plus, I'm sorry. Minus B squared. Okay, so A squared, I already know is 16. B squared, I already know it's 4. So basically you subtract your denominators, okay? If you wanted to plug in back the A and plug in back the B, go for it. It's just a lot of time, very consuming. So you get 12. Okay, now I'm going to do all the work and I'm not going to give the decimal. As in your final answer, you're going to give exact radicals. Okay, so C equals the plus or minus square root of 12. So if I were to break that down, that's 4 times 3, and that's 2 times 2. So that's plus or minus 2 square root of 3. That's the exact answer for each of these. Oh, yeah. Let me zoom out a bit. Okay. Now, I am going to put that in the calculator. You can just put square root of 12. 12 square root. And I want the decimal just for purposes of graphing. Not because you're going to give that as your answer. Please use always exact answers. So this is approximately, I'm going to put here approximately 3.5. Okay. And that's all I need. I can actually graph an entire ellipse without ever having to use any crazy technology or my graphing calculator. We can do a better job than the graphing calculator because this would be a mess. You have to do a lot of work. So let's get started with this. Okay, it's centered at 0, 0. And for purposes of this class, the ellipse and the hyperbolas will only be centered at 0, 0 because anything after that is brutal and we do not have time. And I made this really huge. I don't know why. So I actually fill this in at the very, very end. You see how easy it is afterwards. Okay, so this is what we do. We start by putting the center, which is 0, 0. From the center, I follow my instructions. 4 units, it's plus minus because it's going to go in 2 directions. So it's going to go left, right, 4 units. 1, 2, 3, 4, make it done. 1, 2, 3, 4, make it done. 2, up, down, 2, up, down, 2. And that's my, oh, sorry, that's my ellipse. Okay, now oh, I know why, because this is quicker. The vertices would be the longer sides. Okay, so that would be, so you can see everything. That would be V1, V2, co-V1, co-V2. It doesn't matter who's 1 and who's 2, but it's the fact that these 2 are the smaller ones, they're the shorter sides. So those are the co-vertices. The longer sides are the vertices. And the last thing is the focus points, this will be on the longest side. So it will be 3.5 units, the same way the A moves. So it will be left and right from the center. So at 3.5, I'm going to put a star. 1, 2, 3.5. I'm going to put a star because they're not actual points on the graph. Okay. So make sure that you do not put the focus points on the other side. Even if you try doing it, like let's suppose you make a mistake, you go 3.5 units on the other side. 1, 2, 3.5. 1, 2, 3.5. They are outside of the ellipse. Everything has to be contained in an ellipse. Everything has to be contained in that little egg. So if you accidentally put these, sometimes they'll come out and you're like, wait, that looks weird. So they're not outside, they're inside the ellipse. So that's one way to check. That's if this number is bigger than the 2, you can tell. Okay, and now I'm gonna do is just transfer that to here. So the vertices, the coordinates would be -4, 0, and 4, 0. Those are the coordinates. These 2 are 0, 2, 0, -2. And then the foci, you're going to use this point, the reduced radical and you just take the same format of this. So that'll be 2 square root of 3 comma 0 and negative 2 square root of 3 comma 0. And that's how you have filled everything out. We can also do domain and range. Domain goes from negative 4 to 4, negative 4 to 4, bracket. Range goes from the lowest, negative 2 to 2. Done. So I have done everything I could on this problem, and that's basically what you will see on your test. Okay, let's do one more, just to practice this once more. Okay. All right. I guess as long as I don't write with the marker, it's okay. All right, let's do another one. B. X squared over 9 plus y squared over 25 equals 1. Okay, let me remove this right here because I'm having a really hard time. Cross this in my face, literally. Oh gosh, I'm struggling here. I don't know why I did that to myself. Okay, so let's get to it. First things first, we are going to write everything out. Center. Vertices. Co-vertices. Foci. Okay. Next thing, we want to just on the right side, I mean, you're going to have this on as a note card, but I have to keep writing it to help you out. A squared is the largest, and center is HK, which again, I will put at 0, 0. Okay. Here we go. Center, 0, 0. A, B, C's. All right. So look at the denominators. A squared is the largest. That would be 25. A squared is 25. Therefore, B squared is 9. So A equals plus or minus 5, because you take the square root of both sides. B equals plus or minus 3, because you take the square root of both sides. You look under the 25. Look at the 25. It's under the Y, so that goes up, down. The 9 is under the X. X runs left, right. Those are basically the directions that you're going to run this, okay? The other thing is now finding C. So C squared equals A squared minus B squared. A squared was 25 and B squared was 9. How is that going to run? It's going to run in the same direction than the A, okay? So always note that it's going to run in the same direction as A because A is the longest. A is definitely the longest, okay? So that's 16, therefore C is plus or minus 4, and that's going to run up, down. From the center, always from the center. Okay, I'm done. That's pretty much it. So let me see, left, down. Thanks. All right, center, started off with center. Now follow your own instructions, assuming they are correct. 5 up, down. 1, 2, 3, 4, 5. Make a dot. 5 down. 1, 2, 3, 4, 5. Make a dot. 3 left, right. 1, 2, 3. 1, 2, 3. Make your ellipse. That was so much better. And then you're going to go up, down, 4 from the center. 1, 2, 3, 4. Make your star. 1, 2, 3, 4, make your star. If you accidentally made them sideways, you would note that they would come out of the page, not the page, the ellipse. The longest side is V1, V2. The shorter ones are co-V1, co-V2. And then these stars are F1, F2. And from there, you can then extract these points and put them here. So the vertices are the longest ones. They are 0, 5 and 0, -5. I hope you know how to extract those points. Over here, -3, 0 and 3, 0. And then the focus points are going to be in the same format as this. So it's 0, 4, 0, -4. And that's it. You're done with the next this. Okay, let's do quickly the domain and the range, which is fairly easy after we did the most complicated stuff. Domain is left and right. How far it goes left and right? It goes from -3 to 3, and it goes as high and low as -5 to 5. Done. We are done with this problem. We can't do any more. That's already a lot, but they're very easy, very simple once you get the hang of it. They're not too bad. I personally like these better than the parabolas. Just my personal opinion. Okay, now what we're gonna do is you're gonna graph the next problems, but I'm just gonna get you started on the format so you know how to do this. Okay, so for this one, for example 2, it says graph label and fact. So you're gonna graph it all, label everything, go ahead, but I'm gonna help you get started with just, so that way I did 2 and you do 2 with the graphing. I'm just gonna help you get started with the algebra. Now, we said 3 things about the format. Number 1, both variables have to be squared. They are. Number 2, they are equal to 1. That is not the case. Number 3, they have denominators. That is also not the case. So these are in the incorrect format. It does not mean that there are not ellipses. It just means that they're not in the correct format. So the first thing you need to do is you have to make this a 1. In math, the way you make a 1, you can create a 1 is by dividing by the same number. Okay, just like we had the matrices. So you would divide by this number. Okay, are you going to end up with fractions? The answer is yes. That's the whole purpose. You have to end up with fractions. So then this gives you a 1. 9 goes into 36 4 times. So this will give you y squared over 4. And we want a fraction. And 4 goes into 36 9 times. So that'll be x squared over 9. This is what you're going to use as your beginning function to graph. Okay, it is equal to 1. It now has fractions and x squared, y squared with the plus in the middle. Now you can get started with it. Okay, let's do the last one. 64. Okay, that equals 1, which is what we wanted. Here, there's nothing to cancel or reduce, so it just stays as y squared over 64. And here, 64 goes into, 4 goes into 64 16 times. So that's x squared over 16. Now you have denominators. Now you can get started with that. Okay, so I just got you started with the format. You can go ahead and graph. Graph the same way I did the others. Okay, one will be horizontal, the other will be vertical. All right, looking at the next one. That one says, write an equation of an ellipse having center at the origin and foci 0, 3, 0, -3, and major axis 8 units long. So the major axis is the longest side, and they are telling me how long that line is. Okay. So for these, anytime they ask you to write an equation of any of these conics, I always make a mental picture, and I actually, write it out because it's so much easier. If you want to just do it all in your head and you're like, I got this. If you got it, that's great. But if you don't, you might want to take a picture, a mental picture. Okay. So, oops. Curious. All right, so let me write the information down. Center is 0, 0. Foci, 0, 3, 0, negative 3. Major axis, so the longest side measures 8 units. Okay, that's all I need. Like this. Okay, and there will be one more problem after this before I now do the hyperbolas. All right, so I'm gonna make a quick sketch. You don't need to, the question is not to graph, it's to come up with the equation, okay? So equation, all right. So let's, knowing that this is at 0, 0, it's gonna be x squared over some number, I don't know what that is, plus y squared equals some number equals 1. That's the format, okay? And that's the format if it's centered at 0, 0. So here's 0, 0. 0, 3 is 1, 2, 3. It's up here. And that's a star. That's not a dot on the actual graph. Down, 1, 2, 3. That's another star. So that's F1, F2. Focus points are the letter C. So this amount of units, up and down, that's C. So my C is 3. I know that for sure. Now, if it's an ellipse, wherever the focus points are, that's where the major axis is, okay? And so it'll be that many units long. It is a total of 8. So 8 divided by 2 is 4. That means it goes up 4. 1, 2, 3, 4. And 1, 2, 3, 4. So I know it's going to be like that. I don't know how wide it is. I know it can't be wider than 4, because if it is, then it'll be a horizontal one, and it can't be. The focus points are on the vertical axis, so that's where the longest part is. So that means that the longest part, remember in an ellipse, A is the longest, so A is 4, because that's the amount of units. So when you graphed it, you went the other way around. You had a number, and that's the amount of units you went from the center up, down, left, or right. So I've got my A, I've got my C, now I need my B. So C squared equals A squared minus B squared. That's 3 squared equals A squared, which is 4 squared minus B squared. I have to solve for B squared. You do not have to solve for B. You can if you want, but you're going to end up squaring it anyway. So A squared is 16 and C squared is 9. This is the information, right? I'm going to, here it is 9. This is 16 minus B squared. Okay, it looks like you can end up with a negative, but it actually isn't the case. It's a bit deceiving, but you won't, so don't worry. Move this over, negative 7, negative B squared. So B squared equals 7. You can stop here. If you wanted to, you can do that. But watch what happens. When you actually give the equation of an ellipse, like I said, you do not have any decimals, you do not have any radicals, you do not have any approximations, you have exact answers. So this is useless, but I'll show you right now. So if my largest number is on the y, it means that that number has to be underneath the y. So I should be having x squared, y squared equals 1. My a squared better be under the y. Because remember, a squared is the longest, and that's on the long side. And this should be b squared. So my final answer should be x squared over b squared is 7. A squared was 16. Now, if you had put square root of 7 as your b, you still have to square it. So when you square it, you still end up with 7. Okay, so that's just, I think, a waste of time. But some people would like to do that. They actually solve for b and they end up squaring it. And so anyway, whatever the case is, whatever works for you, as long as you get the right answers, that's fine. If you don't get the right answers, change your method. Change your method. Okay, let's do the last one for ellipse. The last one is not graphing, it's just algebra. So the next one is find the standard form of this following equation. 4x squared minus 16x plus 9y squared plus 54y plus 61 equals 0. So your job is to put it in the same format that we have then halving, it will be x squared over a number plus y squared over a number equals 1. Okay, so this one will be a bit complicated, doable, however. You're going to be doing, again, the completing of the square. Okay, so what we're going to do is keep these, move that. So that's 4x squared minus 16x plus something. I'm not going to put the box just yet because there's something else I need to do. Okay, so I'm not going to put anything yet on the right. So there's something else. Okay, now here's the issue. When completing the square, you do have to have this to be a 1. That cannot be any other number other than a 1. So that's the issue. So what we're going to do is we're going to actually factor out the 4. X squared minus 4x plus the box. Factor out the 9. Oh, forgot a square. 6y plus now the box. Now, oh, fine, let's make it all. On the right side, okay, so here's where I want to caution you. When you are working with these problems, be super, super careful. I do not just put box plus box, okay? The reason for that is because this box is not just there. There is a 4 being affected. So before you can add the box, it actually has to go through multiplication with the 4. So when you put these, you have to actually put the 4, then the box, then put the 9, and then it's box. Because that number is not just going to be adding a 25. Let's just say it's not going to just be adding a 25. It's going to be adding a 25 times this 36. Sorry, times the 9. Going ahead of myself, this is 36. So this 36 that you're going to put in here, or 9, whatever number that is, which will be a 9, that 9 is not just going to be a 9. That 9 is being affected times that other 9 on the outside. So be careful. We're going to complete the square in the same manner. And so that equals -2 quantity squared. So that's a 4. And so that 4 would have had to multiply with that 4. That's how you have to put it here. So these are multiplying, these little boxes. Over here, you take 6, cut it in half, square, that's a 3, square it, 9. 9. Okay, now you can do the math. So this 4 is here. You do the same thing that we did before. You basically take that x, bring it down, copy the number before you square it. Bring that 9 down. You're not doing anything to that 9. It just needed to be a part of this part over here. That's all I'm saying. Y plus 3 squared equals -61 plus 16 plus 81. Okay. That's what I needed to do. All right, so this is 36, 9, y plus 3 squared, x minus 2 squared, and a 4. All right, I'm almost done. This kind of looks like a circle, but it's not. It's a deviation of a circle. But this needs to be equal to 1, so then I divide everything by 36. And that means that this now is a 1. Anything divided by itself is 1. This 9 goes into 36 4 times, and this 4 goes into 36 9. So I have that over 4, x minus 2 over 9. Done. That is your final answer. Okay. And that is the last one I will do. You can try number 4. Graphing that when the center is not at 0, 0. Okay. I will then into the hyperbolas. Okay, the hyperbolas are the ones that are just messed up all the time, every single year. And I try to explain it, but I just don't think we have enough time to have students practice it. So I'm going to try to explain this. It looks like a mess. Okay, these are the hyperbolas. The hyperbolas, in terms of the equation, the top part and the bottom look exactly the same as an ellipse. The only difference is this minus. So if I give you two equations where you've got number on H, number on K, number at the bottom, you won't be able to tell whether it's an ellipse or hyperbola unless you look at the sign in the middle. If it's a plus, it means your two, think of it this way, your two parabolas came together and created an ellipse. If this is a minus, you're taking the difference, so they're going away from each other, and that's basically what you have. So you basically want to think of a basketball court, okay? That's the shape that you have. You have two parabolas on both sides of the court. That's what they look like, okay? This box right here, the box and the asymptotes, you'll have two asymptotes, are not a part of the graph, but they are helping you graph the parabola. If you don't make the box first with the asymptotes, you cannot graph the hyperbola. Students make the hyperbola and then make the box later, and that does not make sense. I'm talking too much. So in this case, when you see a minus in the middle, that should be your cue to say, yes, this is a hyperbola. The next thing is a squared will not be the largest. I repeat, a squared will not be the largest, which is very important for you to make your note card and make these distinctions because it will not be the largest. It is the number underneath the positive variable. And for purposes of this chapter, this class, the final exam, a squared will always be the first one in the hyperbola only. Okay, let me say that again. A squared is the number underneath the positive variable, which will always be the first one in a hyperbola, not the ellipse. The ellipse is the largest one. Center, HK, that's all you need. And the last thing is, now you see the Pythagorean theorem. And I'll show you why that's the Pythagorean theorem. It will be a right triangle, that's why. Okay, so let's get started. That's pretty much it. It'll have a different way of graphing. Notice that the hyperbola is this way and this way for this example. And the focus is inside the, it's inside the parabola. Parabola is one, hyperbola is more than one. So you have the focus in here, okay? So the ellipse contained them inside, okay? It was inside, but the parabola split this ellipse, twists them outside, and it's always on the inside. So it's very similar to a parabola, where it doesn't matter how you twist it, right? Like let's say this is a happy parabola. In the parabola section of 8.1, you have a happy parabola, the focus is in. If I move my parabola to the left, it's still inside. If I move it down, it's still inside. If I move it to the left, it's still inside. It doesn't do this. It doesn't have like here, and it goes outside. That doesn't work. It's always inside. So that's the same idea. No matter how I make these parabolas, you'll have two of them. If they're sideways, the focus points will be inside the parabolas. Okay. So vertices will be the vertices, just like in a parabola from 8.1. The covertices, we don't have any covertices. And all we have is covertices. We have focus points and we have the asymptotes. So let me help you get started. This is a bit brutal, but we're going to try our best. Explain this. All right. So this is graph x squared over 25 minus y squared over 49. Okay, again, three things that distinguish the ellipse from all the rest. Two of the variables are squared. That's thing number one. Thing number two, it is equal to 1. That's what you need to note. Thing number three, there's a minus in the middle. That's how you distinguish this one from the rest. All right, let's get started. Same idea, center, vertices. We do not have co-vertices. We just have foci. And then we will add asymptotes. Again, for purposes of this class, for purposes of this chapter and this entire final, you will not be working with hyperbolas that are centered away from the origin. That's way too crazy. You'll see why in a minute. Okay, we need to know two things. C squared equals A squared plus B squared. A squared will be under the positive variable. Doesn't fit, so I'm going to just put it like that. And then center is HK, which in this case is 0, 0. Okay. All right, let's get started. A squared is underneath the variable. Okay. A squared is 25. Oh, this is not working. B squared is then the other one. Okay. A is plus or minus 5. B is plus or minus 7. Same idea as the previous one. If the number 25 is the A and that's under the X, it's going to move left, right. If the B value, that number is underneath the Y, it's going to move up, down. Okay. From the center. Easy as that. However, the only difference is when you put the dots, you do not connect them to make an ellipse. You instead make a box. I'll show you that in a minute. Let's do the C. C squared is A squared, which is 25 plus B squared. Okay, I'm going to always put, always to the, I'm always going to do the exact answer, and then you can work through the rest. So I'm going to put C equals plus or minus square root of 74. That's what I'm going to use. That's what I'm going to use. That's what I'm going to use. And I'm going to round it just for purposes of graphing, but don't put that as your answer. You want exact answers. Okay. Approximately 8.6. Okay, let's get this started. Left, right, 5. So it's going to be longer than it is wider. Yeah, that's fine. Let's use this line already, since I already made that mistake. Okay. All right. Okay. Center 0, 0. Okay. A is going to move 5 units left, right. 1, 2, 3, 4, 5. Now, instead of making a dot, or you can make a dot if you want, but I'm going to make a dash. 1, 2, 3, 4, 5. Up. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oh man, I should have made it wide. You'll see why. Okay, so before, if we were doing the ellipse, we would basically take these dots and make an ellipse, and that would be our shape, right? But we are not working with ellipses, whatever you want to call them. We are working with hyperbolas. So therefore, you're going to make a box, and that's going to give you the width of the parabola. Otherwise, you're going to have to do points, and we don't want to do points. That's a very complicated equation. So you're going to get your ruler, okay? You're going to make a dashed box, because that box is only to guide you to graph these parabolas, but it is not a part of the actual graph. So I'm going to dash it. I'm just going to go like that. Let's do it with the hand. Okay. So with this information, with these two, just those two, you're gonna make a box. Then through the corner of the boxes, you're gonna make your asymptotes, which are going to guide the width of your parabolas or your hyperbola. So you're gonna go like this. My ruler is not long enough, but that's not the point. This line is gonna go through the center. It's gonna go through the middle, 0, 0. Let me just make it long. And you're gonna do the same thing on the other way. That was a bit quicker when you try doing it yourself. It's kind of quicker. Okay, so no, that's it. Okay, so I know that's so beautiful. Look at that. All right, now I have no idea if they're gonna go this way or they're gonna go that way, right? I have no idea. What you have to do is look back at your equation. The first variable, the positive one, is the one that gives you basically all the information. So that gives you the a value, and it also tells you which way it is. So if I have x squared, so if you look at this picture, notice that x squared is first, they're going to be on the x. When y is first, they're going to be on the y. Okay, so these are going to go sideways. So it's going to be really wide. So what we're going to do is this right here is going to be the vertex of that parabola. It's going to be the other vertex. So this is V1, V2. That'll be here. So my vertices are going to be negative 5, 0, 5, 0. We got those down. And what you're going to do is you're going to just try your best. Grab this and you're going to make a parabola that's going to get close to the asymptote. Not touching this wall, not touching that one, but just kind of curving outward. Doing the same thing here and doing the same thing here. That's how you graph it. Okay. All right, the focus points are that amount of units from the center out, as you see in this picture, on the curvature of the vertex of the parabola. So that's about 8.6 units from the center. So that's 5, 6, 7, 8.6. That'll be here. 5, 6, 7, 8, and somewhere here. That is F1, F2. Remember how vertices and foci are always related. So it'll be square root of 74, comma 0, negative square root of 74, comma 0. Okay. All right, we need one more thing. One more thing. Move that down. One more thing. And it is that we need to find the equation for the asymptotes. Now, the asymptotes are actual lines. Okay, so because for this, this class, you will not be having these graphs be anywhere but centered at the origin. That means that I'm going to make it very easy for you. Okay, I'm just going to do the rise over the run. Rise over the run. So it'll be y equals the rise over the run, and then your x, right? Okay, so from the middle to a corner, it's 1, 2, 3, 4, 5, 6, 7 units rise. 1, 2, 3, 4, 5, 5 units run. So my equation will be y equals plus or minus. You put plus and minus because there are two. One going this way, one going that way. You can separate them, but for purposes of this, because I'm running out of space, I'll do a rise of 7 over 5x. Those are my asymptotes. And this is the final product. I know it's a bit brutal, super brutal. I will do one more. You can attempt number 3, and then I'll do 8.3. Okay. All right. Do one more. One more. It's complicated. Okay, example 2 is 25y squared minus 4x squared equals 100. Okay, for these problems, and I hope I fixed it. It's supposed to be 100. I had originally put in 9, which gave us a fraction. So for this one, are both variables squared? Yes. Is it equal to 1? No. Is there a minus in the middle? Yes. So we know it's a hyperbola, but it is not equal to 1. Do we have fractions? No. So I have to divide by 100. That's my first step. So I get that goes 4 times. So it's y squared over 4. This goes into that 125 times. And that's 1. Okay. All right. Let's get this started. C squared equals a squared plus b squared. A squared is the positive one underneath the positive variable. Center is HK, which will be 0, 0 for these cases. Okay. Center, vertices. I'm just going to abbreviate here. Asymptotes. So that's 0, 0. That's all I know so far. Okay. Let's do the work over here. A squared equals something, b squared equals something, c squared equals a squared plus b squared. Okay. A squared is the one underneath the positive, so basically the first one. The second one is b. So a equals plus minus 2, b equals plus minus 5. I'm going to put the arrows. The 4 is underneath the y, that moves up, down. The b is underneath the x, moves left, right. The c will be 4 plus 25, which is 29. So c equals plus or minus square root of 29, and it's going to move in the same manner than the a, up, down. Okay. I know I went over that a little bit fast, but that's because now you should be able to see and get the hang of this. Okay. Okay. So now the vertex is, I don't know, folks. I don't know. I don't know anything. So we're going to stop right here and just graph it. Okay, up, down 2, left, right 5. Okay, shouldn't be that big of a graph like last time. Move it up a bit. Okay, there we go. So far, so good. Let me move this. I can't work with this. Okay. Center, 0, 0. Up, down 2. Up 2, down 2. Left 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's no point in me putting dots because they are not dots anyway. I'm going to start making a box. So I'm just going to go this way. Okay, and now you're going to take your ruler. So first you make the box. You're then going to take your ruler, and from the corner to a corner through the middle, you're going to draw this. I'm so sorry about that. It's not one thing, it's another. It's like a train, it's a trash can. All right, or a spider. We never know. Life is full of surprises. Okay, just like that. Oops. So I moved it. Okay. Now we have plotted all the information that we could. We have nothing else to do. All we need to do is figure out whether my picture will be this way or this one. Okay. You have the first variable that tells you a lot of information. It's the y, so they're going to be on the y. So that means, again, they're going to be super wide. I'm sorry about that. So between the corners, in the middle right here on the y-axis, that's your vertex. So that's V1, V2. Therefore, that's 0, 2, 0, -2. And you're just going to make this super wide. Like that. Okay. The focus points are going to be inside these parabolas. So that's why you always want to draw them first. And then you're going to take 29 and take the square root of it. That's a little bit over 5. Okay. So it's about 5.4, 5.4. And that's just a graph. So it's going to be 1, 2, 3, 4, 5, and something. The wider, I don't know if you've noticed, but the wider the parabola is, the higher the focus is. 2, 3, 4, 5. F1, F2, so it'll be 0, square root 29, 0, negative square root 29. Boom, we're done. Last thing would be the asymptotes. So there will be y equals rise. You're going to go rise over the run. So from the center to one of the corners, you're going to just put plus minus. I'm going to rise 2. It's basically going to be either A divided by B or B divided by A. So, but instead of me trying to memorize it, because the book has a whole bunch of formulas to memorize, I try to understand it, and I can visually see that it is 2 over 5. Let's suppose you even messed up the parabolas, like you graph them this way, the asymptote still won't change. You can still get all this information partially correct. Okay. All right. And that is that for 8.2. We've got one more thing to go over, and that would be the eccentricities. So eccentricities, if you had some kind of equation and they asked you what kind of equation is it, you can figure it out by the eccentricity. Eccentricity is just a fancy name for just a number. And it is not the E that is found in the calculator. When you were doing logs, it is not that, okay? They just put E for eccentricity, but it is not that number. It is not a number. It's literally, legitimately a letter. Okay, so all you have to do here, this is all algebra. Let's see if I can grab another sheet of paper. Brown paper. Maybe, maybe not. Yes, I did. Okay, so these are just algebra stuff. You're not going to be graphing at all. Okay, so for this one, it says find the eccentricity, which is C over A, where C is a focus and A is a vertex. Okay, so all you have to know is what kind of formula it is, how to find your A and how to find your C. So for A, x squared over 9 plus y squared over 16 equals 1. This is an ellipse. An ellipse for sure. It's equal to 1. It's got denominators. It's got a plus in the middle. Both variables are squared. Ellipse by definition. That means that a squared is the largest. Okay, so a is 4. Here you don't need to do the plus minus because you're not graphing, but you do need to find the c. And remember, you have to know there are two different formulas, one for the ellipse, one for the hyperbola. So you have 16 minus 9 in this case, okay? So c squared equals 7. So c equals square root of 7. Okay, now to find the eccentricity, very simple. Eccentricity is c over a. So eccentricity, your c is here, square root of 7 over your a. We needed to do all of this to figure it out. And then if they ask you to round it, then you would take square root of 7 square root and divide by 4. 0.66. And if you look at the book, which you have available on Pearson, and you go to 8.3, you can tell what a conic is by just knowing the eccentricity. So if you had an eccentricity here, if they give you an eccentricity of between 0 and 1, that has to be an ellipse. The answer that we got was 0.66. That number is between 0 and 1, so it had to have been an ellipse, and it is true. Okay? That's basically all you do. This is just pure algebra after you have gone through all the conics and understood how to get A, B's, and C's. B, we've got 5x squared plus 10y squared equals 50. That is also an ellipse. However, it is not in the correct format. So we're going to have to divide by 50 everything. So we get, let's put it here, x squared over 5 goes into 50 10 times. 10 goes into 55 times, and that is a 1. Again, you don't have to graph. So some of these will be square roots of horrible numbers, but that's not to judge. Okay. So when you're dealing with this in an ellipse, because it's a plus, you take the highest one to be a squared. B squared is 5. Therefore, a is square root of 10. B is square root of 5. And then you find your c. Okay. So c squared equals a squared minus b squared. C squared equals 10 minus 5. So c squared equals 5. Therefore, c is square root of 5. So for my eccentricity, it's c over a. Okay, so because it's an ellipse, I should have a number between 0 and 1. So when I take square root of 5. Also this, because there's a rule, I don't know if you know, that's the same thing. Okay. If you have a number, a square root of a number on the top and the square root of a number on the bottom, it's the same thing as the square root of both numbers divided, which is a half. If you divide 5 by 10, you can put in the decimal, whatever is easiest to you, doesn't matter, but you can do that. And then that'll give you, notice I'm running out of paper. You can just do the square root of that, which is 0.707 or something like that. Okay, depending on how many decimals they want you to round it up. All right, not too bad. We've got one more to do from the notes, and that would be the hyperbola. Now, notice that on the notes, I'm telling you which kind of conic it is. Not necessarily will you have that on the homework or on the test. So know when to identify a circle from an ellipse, from a parabola, from a hyperbola. This is one more sheet. Yeah, I did not want to waste. Here we go. Okay, last one. Yes, and we are done with chapter 8. Okay, if I had this formula like this, even if I didn't tell you what kind of conic it was, you should know because it's equal to 1. It's got both variables squared, and it's got a minus in the middle. That minus means it's a hyperbola. Okay, that means that when you are looking at the a squared, you look at the very first one. You don't look at the largest. It just so happens in this case that a squared is the largest, but that's not the reason why. Okay, so a squared is 9, therefore a is 3. B squared is 4, therefore b is 2. Now, be super careful. This equation is a squared plus b squared. It's not a squared minus. So that's the difference. So when you know the conic, you have to please, please, please make sure that you know which I'm not sure what happened if this video got cut off. I think it stopped sharing for some reason. Let me share again, I guess. Okay, so I think it's still recording. I'm not quite sure. All right, so I did the math and I got 1.2. 1.2 is a hyperbola according to the book, where I showed you, and this you don't have to know, okay? But it is just in the book, and it just gives you an idea of why it's a hyperbola. That's because it's greater than 1. That's all. Okay, that was a 1.2. All right, I hope it didn't get messed up, but that is the end of unit 4. I'm sorry, unit 8. Hey, it was at least a multiple of it. Yeah, so this is done. Conics, study, and practice. Let me stop sharing and stop the recording.